So x of s for the infinite limits integral x of t e power of minus st dt. And since we have a conjugate for x of t here, so applying the conjugate on both sides, or trying out to find the conjugate on both sides. On left hand side, what will we get? X conjugate of s equal to infinite limits for the integral. X of t now will get a conjugate, and this e power of minus st will also have a conjugate. And dt. So we have to have a clear understanding of like how this e power of minus st conjugate can be written. So for that, we know that s is sigma plus j omega. So e power of minus st is written as e power of minus sigma t e power of minus j omega t. Now e power of minus st whole conjugate means, can you please tell me the first exponential, is this a real exponential or a complex exponential?
Real exponential, sir.
So it is a real function, real exponential. Second one, obviously you can see j. So this is a complex exponential. Okay. So this conjugate will be applied for both the functions like this. And since the first one is a real exponential, it remains as it is. And next, the second one is a complex exponential. What is the answer if we apply the conjugate?
E power j omega t.
Right, e power of j omega t. Okay. Now, how can I write this? Equal to e power of,
E power minus sigma plus j, okay, minus j omega of t.
okay, nice. Now, going up, if s is sigma plus j omega, can anyone tell me what is s conjugate?
Sigma minus j omega.
Sigma minus j omega. So s is sigma plus j omega, s conjugate is sigma minus j omega. Right. Now, can you see this as e power of minus s conjugate t? Can I write like this?
Yes, sir.
Okay. So therefore, here, this part I am writing again. So x conjugate of s is equal to integral infinite limits x conjugate of t e power of minus s conjugate t dt. Am I right now? Till now? So e power of
Yes,
minus
sir.
st whole conjugate is written as e power of minus s conjugate t. Right. Now, just comparing this with the original Laplace transform formula, x conjugate of, sorry, x of t e power of minus st dt. Uh, Did you get the direct comparison between these two, or should I make any change for this? You can see integral remains the same, but dt also remains the same. But this e power of minus st here is not e power of minus st here. There is a conjugate. Okay. So what I do is, in this, I am going to replace s with s conjugate. Replacing s with s conjugate. Now what happens to this? X conjugate of s conjugate equal to infinite limits. This remains e power of minus. What is s conjugate whole conjugate?
S itself.
S again. So you will get here s conjugate of whole conjugate. You will get s itself. Now can you get a comparison between these two now? You have the same formula. You
Yes,
have the
sir.
same e power of minus st. You have the same dt. Only function has changed. So this is our x of t, x conjugate of t. X conjugate of t will have the Laplace transform as x conjugate of s conjugate. Is this clear? Till this.
Yes, sir.
So I'm going to replace this question mark with x conjugate or s conjugate. Nice. Now, what about the ROC? What about the ROC? Question mark. It should be replaced.
R only, sir.
R only, sir.
R only. Can you justify how it is R only? Your answer is correct.
Sir, because the conjugation depends only on the imaginary part, no, sir. So there is no change in real part of S. So,
Correct. So S is sigma plus j omega. S conjugate is sigma minus j omega. And since the ROC depends only on the real part, you observe that even though we have a conjugate here, sigma doesn't change. Therefore, the ROC remains the same R. Good. So ROC is the same R. Okay. So this is all because of no change in the sigma.